In this video, we are going to create this chest opening effect in Unreal Engine 5 using blueprints and Niagara. We'll quickly set up the chest opening logic using blueprints and then move on to the main focus of this tutorial, the Niagara effects. So let's get started. I already have the third person template open, and the first thing we need is a chest model. I go to Window, Fab, and search for chest. I select this one here and add it to the project. Once it's imported, I locate the model and open it. It looks decent, but there's a small shading issue which can easily be fixed. For that, I open the textures folder for this mesh and open the normal map. In the advanced settings, I uncheck this flip green channel option. Save it. And now the shading looks much better. However, this is currently a single mesh and I want the lid to be separated from the rest so we can animate it easily. So I drag the chest into the scene and switch to modeling mode. Under the select tab, I choose try select and change the selection method to UV island. Now I select the top part of the chest. Make sure to include all the inside faces as well. With that selection, I click separate and Unreal separates the selection into a new mesh. Next, I need to adjust the pivot point of the separated lid. Right now it is not in a useful position. I want it to be around the hinges so the lid opens naturally when I rotate the mesh. So I go to X-Form, Edit Pivot and move the pivot to where the hinges are. To make this easier, I switch the viewport to unlit and change to a top view. Now move the pivot so it sits between the hinges. Hit accept to save the changes. Then with the lid selected, here in the details panel, I click this button to locate the mesh in the content browser and move it to our original folder like that. Now we have our chest mesh set up correctly. I can rotate the lid like this to create an opening animation. Finally, I delete these meshes from the scene for now. Switch back to selection mode and rename the lid mesh to chest lid. I make a new folder to store everything related to this effect. Inside it, I add a new blueprint interface and name it BPI Interact. Open it and I rename the default function to finteract. That's all we need here. Next, I create a new actor blueprint and open it. With the chest mesh selected in the content browser, I click add and add it as a static mesh. Then I select the chest lid in the content browser, select the chest mesh here in the components hierarchy and click add static mesh. This adds the chest lid as a child mesh. I adjust the lid's position so it sits correctly on the chest. I want the chest to face the global forward direction, so I select the chest mesh and rotate it 90 degrees, -90. Then go to class settings and here in the interfaces, I add the blueprint interface we made, BPI Interact. Double click this to add it to the graph. This is where I'm going to make the opening animation. I add a new timeline node. Plug it to play from start. Inside the timeline, set the length to 1. Create a new float track. Make a new key. Set it to 0, 0. Make another key and set it to 1, 1. And set both keys to user. Now back in the graph, drag and drop this here. And when this timeline plays, I want to change the rotation of the chest lid. So I plug a lerp into here and use our timeline track as the alpha. And when it goes from 0 to 1, I want the lid to rotate -90 on X. Then I want to call this event from our third person character blueprint. So open BP third person character. I add a keyboard event for E key. From there, I get overlapping actors and set the class to BP chess. After that, I add a for each loop with breaks. Plug this into here. If we have multiple chess actors overlapping in the same area, this for each will help us open just one. Then I see if the chess implements the blueprint interface. So, does object implement interface? And select the interface. Based on this, I make a branch and then execute the interact event. Once the interaction is triggered, I break the for each loop. At this point, the interaction logic works, but we don't yet have a way for the character to detect the chess. So, back in the chess actor, add a box collision component. I scale it up and position it around the chess like this. In the collision settings, make sure overlap all dynamic is enabled. If I place this chess actor in the level and hit play, then walk up to the chest and press E, you can see the chest opening correctly. Now that the basics interaction is working, let's polish this up with some Niagara. Right click in the content browser and create a new Niagara system. Let's select an empty emitter. I call this ns_chest opening. Open it up. For some reason it starts with a fountain emitter. Not sure why that happens, but that's fine. We'll work with it. I don't want scale color, drag, gravity or any of these, so just delete those modules. I add a spawn burst instantaneous module. Delete the sprite renderer and add a mesh renderer and select our chess mesh. Now I have a reference the chess inside the Niagara system. It's just here as a reference. You can see here it's currently disappearing and reappearing. That is because of a mismatch in emitter loop time and particle lifetime. So in initialize settings, I set the lifetime to direct set and set it to 2. Same value for the loop duration. Then I want to make a bunch of particles rising out of the chest. Right click, emitter and select fountain. I disable scale color, drag, gravity and velocity so we can focus on others. In spawn rate, I set it to 30. For the shape location, I set this to box plane and select plane. You can see particles spawning on a plane here at the bottom. Let's move this plane up. So here in the transform, I set the offset to default and give it 30 on set. For the plane size, I do 90 and 60. Then enable velocity and set it to from point. You can see particles are shooting outwards from the simulation origin. I reduce the velocity to 60 and 85. In initialize settings, I set the particle's lifetime to 1.2 and 1.8. For the color, I select a yellowish one and set the value to like 100 to make it glow. Then set the size to 2 and 4. I want to add some resistance to the movement, so I set drag to 1. Then add a curl noise module and put it above the drag. Set the strength to 50 and frequency to 30. I delete the gravity. And in scale color, I set the alpha to something like this. To scale down the particles over time, I add scale sprite size module. For this, I choose this curve again and adjust the key value like this. That's enough for this. Maybe we can set this emitter to use GPU. Make sure to set the bounds to fixed. Now I disable the previous emitter again. We're only using it as a reference. Save the system. In the chess blueprint actor, I add a Niagara system. Select the system if you haven't. Then here I uncheck the auto activate. In the event graph, I grab our Niagara effect and set active and check new active. Now when we hit play, walk up to the chess and hit E, you can see the chess opening and Niagara system is playing. Actually, I think it is rotated, so here I reset this rotation and it's working correctly. Let's make the rest of the effect. Back in the Niagara system, I want a particle system that bursts out sideways right when the chest is open. So I duplicate this emitter with Ctrl D. Isolate the emitter. This one I don't want to loop, so set the behavior to once. Duration to 1. I delete the spawn rate and add a spawn burst instantaneous module. Set the count to 150. Lifetime I set it to 1 and 2. Color same. And particle size I reduce it to 1 and 2. I disable the isolation and disable all these modules and the add velocity. In the shape location, I want this to be 120 and 80. Offset to 40. Bring it to the opening edge of the chest. Now in the velocity, I set the min and max to 150 and 200 and set the offset to the same as the shape location. Right now the velocity origin is in the middle. I want to move it to the back of the chest so particles would shoot towards the front. Our plane size is 80, so I set this offset to -40. I also want particles to move up a bit after some time, so I add a gravity module and set to 40. Then enable curl noise and let's do 100 and 100. Enable drag. Change it to random range float and set the min and max to 0.8 and 1.2. I enable scale sprite size. For the scale color, I set the graph to something like this. For this one, I set it back to CPU with dynamic bounce. That's because I want to add this light renderer to the particles. Check alpha scales brightness. This renderer only works with CPU. This will cast light on the surrounding from the particles. Enable this emitter and disable this. Play the game and it's working. It's a bit dark inside the chest. We can add a light renderer to this emitter as well, but what we can also do is add a point light inside the chest. I reduce the light radius and move it up a bit. Also, I adjust the source radius. Let's hide the lid for a bit. Now, I adjust the source radius to something like this. I select the color we use for the particles but set the value back to 1. Intensity of the light will take care of the emissive factor. In the event graph, here I grab the point light and set its visibility to true. And in the point light details, set visibility off. Now the chest looks much more alive when it's open. Next, I want to add some glowing rays coming out of the chest. I disable these emitters, duplicate the first emitter, keep the spawn rate at 30, set the lifetime to 1.5 and 2. Keep the same color. Disable these modules and the velocity. Now in the shape location, I set this to sphere. Increase the radius to 30. Set this to 0.5 to only distribute on the top part of the sphere. Then stretch this to fit the chest size, 2 and 0.5 here. So we get a little arc. I set the offset to 50. So when I add long rays, it won't clip the bottom of the chest. Here I enable velocity and set it to 1 and 2, just enough to give particles a moving direction, which we can then use to orient the rays to that direction. Set the offset to -30. Now in the sprite renderer, I align them to velocity. Then in the initialize particle settings, set the size to random non-uniform and set these to 1060 and 25:120. We need a new material for this. Back in Content Browser, I right click and select material. Call it 𝒚𝒐𝒎𝒆. Set the material to be additive and unlit. Enable two-sided. To bring in the particle color, I add a particle color node. Plug it to emissive. Then add a texture coordinate node. I want one axis from it, so add a mask, and I think I need G. Put it through a power node, then multiply it with alpha of the particle color. Plug it to opacity. Back in Niagara, I select sprite renderer, and with our material selected, I click this arrow to assign it to the emitter. You can see now we got these glowing rays. I don't like the harsh edges of the rays, so back in material, I duplicate this. Plug the coordinates and select R channel. Then I do a remap. Hold one key and add a constant. Plug it to target low. Set the value to -1. Then run the results through an absolute node to get rid of negative values. Then 1- to reverse it, and power node after that to smooth the gradient. Next, I multiply it with this and plug it to here. Also, to fade any clipping with other geometry, I add a depth fade node. Multiply with this and plug it to opacity. Now we have much smoother rays. I enable scale color. Actually, I will reduce the glow to 25. Enable these two emitters and disable this. Now we have a full chest opening effect. However, the rays start a bit too early. So in the emitter state, I enable loop delay and give it a 0.2 seconds delay. Actually, let's duplicate this and have a few of these for us to open. I reduce the glow strength even more. I think that works better for me. Also, I want them to be slightly wider, maybe 15 and 35. There's still some clipping happening, so let's animate the alpha over time using a dynamic parameter. Back in material, I will multiply this value, so add a dynamic parameter, multiply it with the first one. You can give it a name from here if you want. Then back in the emitter, I add dynamic parameter module and move it up to here. And for the first parameter, I do a float from curve and select this linear one and bring this key back a bit, like 0.4. And that will multiply with this, and you can see it somewhat makes the rays fade in. I set the keys to user and maybe set this to 0.5. Now I can delete these unused modules. And that's how you can create a chest opening effect in UE5 using Niagara. I hope you enjoyed the tutorial. Don't forget to check my other UE5 tutorials as well. Thanks for watching.